So transistor is the most important word to latch onto in bipolar junction transistor, because transistors of various types are ubiquitous in modern electronics. All transistors are electrically controlled switches or resistors that let a voltage or current affect the voltage or current somewhere else. That behavior is actually baked into the name transistor, which is a terrible portmanteau of transfer and varistor, where varistor itself is a terrible portmanteau of transfer and resistor. Taken together, this means a transistor causes a resistance somewhere else to change in response to a signal. We can draw a circuit model to make this more concrete. Bipolar junction transistors are three-terminal circuits, and I've pictured an example of the bipolar junction transistor circuit symbol on the right side of this slide. The terminals are called the emitter, the collector, and the base. There are several voltages and currents we use to monitor the behavior of BJTs, including the base emitter voltage, VBE, the collector emitter voltage, VCE, the base current IB, the collector current IC, and the emitter current IE. Charge can't build up inside of a BJT, so IE has to be equal to IB plus IC by Kirchhoff's current law. It's worth noting there are two types of BJT transistors, and this variety is called an NPN transistor. We'll talk about the other kind, called PNP transistors, in future videos. As I mentioned before, there are lots of types of transistors, each of which has slightly different behaviors. These include metal oxide semiconductor field effect transistors, or MOSFETs, junction field effect transistors, or JFETs, high electron mobility transistors, or HEMTs, and many others. BJTs are sort of odd ducks in this transistor menagerie because they aren't often used in modern chips. However, BJTs are great learning tools and they let us do math in the lab easily, so we're going to focus on them as we build up the basics of circuit analysis. Out in the real world, you're much more likely to use MOSFETs, which are the most common type of transistor by a wide margin. The other basic information that's worth knowing about BJTs is how they're built. BJTs are intricate combinations of PN junctions. Specifically, they're either NPN junctions or PNP junctions. You make them by creating successively heavier doped regions in semiconductors, as pictured on the left here. The N-well is, this N-type region is labeled the N-well, which is a construction that you'll see on chips that converts them from P-type to N-type. It creates a big N-type region that you can build devices in. So those tend to be large, low doping level implants. Another thing that's worth noting about this NPN BJT structure is that the emitter region is very heavily doped at 10 to the 17th carriers per cubic centimeter, and that heavy doping has a special name. It's often referred to as N+ type doping as opposed to just N doping. Finally, notice that this base region is very thin, and that being able to design this very thin base is an important part of making a BJT. You can see a top view of this transistor on the bottom of the slide, which is the kind of view that you would see as a circuit designer. Circuit designers mostly control X and Y dimensions when making chips, while device designers have pretty exclusive purview over the Z dimension. This top view reveals there's kind of a lot of wasted space in this particular BJT because the contact is surrounded by a ton of area here, and there's dead space there, and there's dead space there. So you might be able to make a more compact BJT by squeezing this to the left and the right. That's wasted area is just a byproduct of this being a illustration. And in production, you'd often see these compressed very close together. The region of the BJT surrounded by the dashed lines is the most important region for the BJT's operation, so we have a zoomed in version of it over on the right. Note that it's been rotated by 90 degrees. We're going to zoom in further on this structure on future slides, so I thought it was important to highlight how this picture of the BJT related to the BJT's overall construction. It's just a zoomed in version of that. So in summary, bipolar junction transistors are a type of transistor, which means they change a current in response to a signal on some other terminal. Transistors have 3 terminals. BJT transistors have 3 terminals: the emitter, the collector, and the base. And BJT transistors are either NPN or PNP junctions that have very specific doping levels and widths. Finally, we introduced our notation for the BJT, which is pictured down here.